No, 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 no.
You're not
It's
having,
warm here.
you don't have to plow the streets.
Yeah, good morning, everybody. No, it's warm.
Yeah, I
I
know. It's
mean, we
summer.
are, yes, we are your equivalent of July in general.
You
Did you hear
know,
me?
yeah,
Yeah,
yeah.
we heard
You
you,
know,
Manu. Let's begin our phone call for this week. It's 11 minutes after the hour. We do have a ground rule on this call to like be at the appointed time and to notify if you're not going to be on the appointed time so that we can actually begin the call. We're moving into 15 minutes after the call. Manu got here relatively early today. It's one of our ground rules is we show up on time, ready for the call at the appointed time. So we're starting 12 minutes beyond the appointed time. Maybe we can do better next time. So welcome to the phone call. I've got word from Richard that he's in Victoria working with being with his daughter who's going through the family crisis there. And then I've heard from Anne that she's going to not be able to make it today. So it's us folks here, and Mano's here in good order. So
So,
what?
just Steve, for me, really, to commit that I will be on time and to advise Rally is very difficult. This meeting start at 5 a.m.
Yeah.
my
yeah.
time. I've got to be up, if I want to be on time at a quarter to and
Well, I
get
appreciate
some
that.
kind of ready. Yeah.
On
So
Wednesday, on Wednesday, the call is at 6 a.m. and I do for me it's 6 a.m. in the morning and I do rock and roll until 2 o'clock in the morning. So I often get 3.5 hours sleep before I get on the Wednesday morning call. I am able to go back to bed after the call, which is good because a lot of people can't do that. So I appreciate that. And still we have the ground rule. And so it'd be great to do the call at the appointed time. And if you're not at the appointed time, you're not at the appointed time. And now we're 13 minutes in, and we're going to begin the call. Manu, how are you feeling today, and what do you anticipate to get from the call?
waking up with my tea
Cool.
and happy to have a sip of it. And it was interesting hearing stories about snow there. I guess I came in when Fred was talking about I would guess snow in China. So anyway, I'm up and ready to go. So what I expect is that we progress. We progress on this book, and then we get the essential of it. We try to apply it to understand better and to create better for as many as we can. Lee, how do you feel? What do you expect?
I'm feeling great today. I did yoga
Mm.
while Steve was working on his computer, and he would occasionally come and help me when I was not able to do what he suggested. And so I was learning a lot more today than I have before. Um, I was trying to bring my right leg over my left leg and looking to the right, and it was difficult to do that with my arms spread out like an eagle, and and then doing it with my, I'll say, the bad leg, though I don't say that often because I'm getting better, but the one that hurts me is my left leg, and I had to do that one, and it was about ready to give me tears in my eyes. But I did it as best I could. I had a great time. What I'm planning on getting out of today, I have no idea. I don't have a book. I wished I did. So I am excited about it to learn new things. Now, Joe, how are you doing?
I'm doing okay. I went through the process of actually packing today. Um, it's been a very
Hmm?
emotional time. But I got a lot done. I have somebody that's helping me and who's not emotionally attached to some of the items that we're going through, so that's very helpful. Really nice person, really nice person. And yeah, it's a process. They got to work through. I appreciate both. I gotta say, both Manu and Steve. I appreciate you guys getting up at the times that you do. There are times that I have to get up at those hours, and I'm not as good. And I remember the one night I was really sick on a Saturday night, and I made it to the call. I was really sick. And I said, as sick as I am, and I threw up that night. I said, as sick as I am, I would not want to be getting up at 6 or 5 a.m. I would rather be sick throwing up than be getting up at 6 or 5 a.m. So either way, that's how I really respect what both of you guys bring. And so it's great. As far as what I expect to take out of the call today, I mean, again, I think the relationships that we're kind of trying between Fridays and Saturdays, or I'm sorry, Saturdays and Wednesdays, are interesting. I feel like we're really kind of into pure Bucky on Saturdays, and then we're kind of making it into, I don't know, it's a little bit, we're getting into other topics like music and things like that on Wednesdays. So it's a little bit more broad on Wednesdays, but it's still maintaining Bucky's concept. So kind of going through these two books in particular. This is a long enough check-in. I'm good. So Fred, how are you doing? What are you looking to take away from today?
Thank you, Joe. Yoga is difficult. Yoga
Yeah.
is very difficult. It's a little bit like Tai Chi. It looks easy when you look at people doing it because they have the strength and the flexibility and mobility to do it. And they would not be on pictures or movies or tutorials. They have not developed this ability. But yoga is a very difficult discipline, both physically and mentally. It's the same as Tai Chi. Tai Chi is difficult. It looks easy because people move slowly, but some movements are more difficult to do slowly than to do fast because you have to support your body weight all the way. You cannot just move across and balance it. So kudos to people that do yoga and Tai Chi or Tai Chi. It's a difficult discipline, and it's if done well and when done regularly and well, it has a lot of benefits for the body. As an aside, yoga was and is still considered a satanic activity by Christians under some circumstances, just so that you know. Next, be on time is important. There's two things to be on time. Is be on time to respect other people's time when you start. And then there's when we close the call and we say how we feel, how do we feel and what is our takeaway. I don't think it's the right time to add something new, show a new sketch and try to push new concepts at that moment. I think it's just a takeaway of what the call is at a close and there's nothing new that should be brought in, just things that have been taken out are to be shared at that moment. That's my feeling. When somebody brings up something new, I always feel, oh, no, we're done here. We are to close, and everybody should just close. So that's my feeling. Then I was practicing martial arts, and every once in a while, the sensei, the teacher, would lecture people that showed up and say, you have to show up. And he was saying that for people that did not show up. So I was thinking that lecturing people for being on time when they are on time, it's a little bit funny. We need to do this at the end of the call, but that's really funny. Anyway, I thought that was interesting, the parallel with that. And then I have in mind something that has stayed with me for the whole week. It's I've got it on a card here. It says, take it before the universe realizes it made a mistake and tries to remove it. So that's how I feel. My expected takeaway, as always, is let's try to learn a little bit something. And Steve, how are you feeling today, and what is your takeaway?
Well, I'm feeling pretty good. I've had an exhaustive week. I've been celebrating my 80th birthday every night this week. It's been really expensive. And what I've done is, as I have this little birthday card that I've been passing out to people. I say, hey, it's my birthday. Here's my birthday card. They say, what? But I have a little birthday card. I pass it out to people. And on the card, it basically lists all the octogenarian rock and rollers that are out there. So, Pete Townsend, Robin Trower, Stephen Stills, Neil Young, Dolly Parton turned 80 on Monday. So anyway, I have this big list of rock and roll stars who, and I didn't bring the card here. I could show it to you, but I'm not. But it's been very exciting, and people go, "You're 80 freaking years old." They don't freaking believe it, and it started to make me feel really tired. So starting tonight, I'm going to be 68 years old. And I'm going to be 68 for the rest of the week. If anybody asks me, I'm going to lie. I'm going to tell them I'm 68. But I'm glad to be here at 80 years. It's really exciting. And I definitely agree with martial arts. And I've been doing yoga once or twice a week for the last 40 or 50 years. And so I'm pretty up. I know what the forms are. Some of them I can do them halfway. But it's really keeping that fascia stretched out and keeping your body going. Tai Chi is the same way. There's a lot of, when one really understands what's going on with Tai Chi, there's a lot of Chi going on with Tai Chi. So it's good that I feel healthy and alive, and I'm very, very grateful for that. As far as our study goes, I agree with the comment that Sunday night the weekend call tends to be more pure Bucky. And of course, that's because we're doing a fuller explanation where Amy here is trying to explain things. And it's pretty cool to come back to all this and doing what I can to make some sense out of it. So we're in chapter 14, which is the cosmic railroad tracks, the great circles. And we're doing about great circles. We left off last weekend on page 239, but I thought that, and it was suggested, and I think it's a good suggestion, that we come back and start on page 238 at figure 14.7 and begin our reading there. Any comments or questions before we launch into the book? Okay, good.
There's your document.
What document? Yeah, I could have shared it. I know, I could have shared it. It was up on my computer, but I decided not to. We've had plenty of excursions today between weather and talking about yoga and time on the call. So we were actually down in here, and I thought, and it was suggested that's really good because we're talking about the icosahedron. This are the 6 great circles of the icosahedron. This graphic here shows the 31 great circles of the icosahedron. So it might be good just to start there and see what we can do to capture up. I'll start reading, and then after a couple paragraphs, anybody who'd like to read can read, and hope somebody wants to take it over and go after I've done it here. The axes defined in the icosahedron's 12 vertices introduce 6 great circles. We already have a pattern with 6 circles, the octahedron, VE, figure 14.4. However, this is an entirely new set out of phase with the earlier group as defined in the jitterbug transformation 14-7. Outlining 12 pentagons and 20 triangles as opposed to 24 isosceles triangles. These arcs present the most symmetrical arrangement of 6 circles. When a vector equilibrium contracts into an icosahedron in the jitterbug transformation, the radius edge length equivalence is lost. But the distances between the adjacent vertices on the surface are suddenly all equal. As an icosahedron produces the most symmetrical distribution of 12 vertices on a closed system, it follows that the same is true for their corresponding 6 great circles. Next, the axes of symmetry connecting the centers of the icosahedron faces generate 10 great circles, while the 30 edges spin out 15 more. So 6 plus 10 plus 15 equals 31. The total circles provide the spherical edges of a pentagonal dodecahedron, as well as those of an icosahedron, and less predictably, also include the octahedron. These relationships will be explored below. So what I actually did with the from last week, what I actually did was I have a thumbnail of that was posted with the oh shoot, I probably moved it out of here and moved it over to the other thing. Yep, I probably did. So we'll come down here and on the external drive. And here's the Bucky backups. And then this should be the, I think this is it right here. So it just really impressed on me the significance of the fact that both of these are icosahedra. One showing the 6 great circles, and the other showing all 31 great circles of the icosahedra. This is the same animal. Starts here, adds great circles at the faces, adds great circles at the edges, and that's a total of 31. So I thought that was pretty significant. And that's what we're, as we read, that's what we're going to, we're expounding on that thing as we go. Least common denominator. The spherical icosahedron divides the surface of the sphere into the greatest number of completely regular domains with both equal arc lengths and equal surface angles. We can therefore subdivide one of these symmetrical triangles to fit the least common denominator of the surface unity in much the same way as we isolate A and B modules. Each triangle is split into 6 equal parts by perpendicular bisectors to obtain a final non-symmetrically divisible unit, figure 14.9a. The result is 120 asymmetrical triangles, 60 positive and 60 negative. The maximum number of equivalent domains on the surface of a sphere. These perpendicular bisectors are the icosahedron's 15 great circles, as shown in 14.9b, which was that second down here. Okay, any comments or questions on this? I'm not sure I understand a positive and a negative triangle.
Upside down.
What's that? What did you say, Lee?
One's upside down, the other is upright.
Oh, is that what you're saying between positive and negative? Does anybody else have, that's a maybe, anybody else have an idea what a positive triangle is as opposed to a negative triangle?
I just think of it as a dual.
Well, I'm gonna positive triangle versus negative triangle. A triangle symbol on electronics like LED in front of panel connectors almost always indicates the positive lead or pin. That's not what we're talking about.
No. Where did you get that?
There's positive and negative curvature, but I don't think that's what's there. When you have a triangle or a sphere, that's positive curvature. When you have a triangle and a hyperbola, that's negative curvature. But I do not think that's what we're talking about here.
Yeah, the internal angles of a triangle are always positive values, summing up to 150, 180, I mean, or pi radians.
Well, okay, so that's what it is. A triangle and a sphere delimited by grid circles or not delimited by grid circles, just a triangle and a sphere, the sum of the angles is more than 180. Whereas if you have a triangle on a hyperbola in hyperbolic space, then the sum of the angle is less than 180 degrees. The sum of the angles of a triangle being 180 is only on a flat plane, Euclidean flat plane. But I do not know where that comes from, 60 positive and 60 negative. It's unclear to me.
Yeah.
Manu, you have an idea?
Manu, we can't hear you, my friend.
This is the icosahedron. Look at my thumb and my...
Oh, yeah.
Yeah, this is positive, this negative. This one is seen, that one is hidden. That's what it means. And as I just said, the dual of it. And if you look well, this one like this, in regard to this, the view looks down, that one looks up. This looks up. Gosh.
Oh, nice. I have the same exact one, but no.
Here, if I take any pole of the icosahedron, and there are 10 poles, 10 axes, 10 polar axes. Look at these two. If you look this triangle here that you see is up like that. If I turn it like this, you see my thumb where it is. My thumb was here. That triangle is down.
Aha.
This,
So one's
this,
positive
this,
and one's negative.
yes, this one is seen. Positive is seen, is radiative. By convention, is seen. Negative is gravitational.
Has this convention been defined earlier in the book?
We've always used it, all over. You always have a pole, a positive and negative pole. You have a Jose duality.
Yes, but does this relate to those 60 positive and 60 negative triangle? I'm sorry, my mind doesn't make the connection there.
I just
the
found
first thing you ask,
especially when you use words like up and down to define them, it makes it difficult for me.
Okay. Let's just take this one. You see the black?
Yes.
How does it orient?
It pointing down.
It's pointing down. Yes. I turn this.
Okay. No. Don't turn it this way. Turn it this way.
Whatever the case, you turn it that way. Where was it again? If I turn it that way, this one looks up.
Okay, we need better word than up and down to define that, but I agree with you. But is that convention that you say that we always have this convention that the dual is a positive and negative, is that somewhere defined in the book, earlier in the book?
That is a fundamental. You don't have that, you haven't got it.
Okay, where do I find this fundamental of principle?
The fundamentals say in duality, the two parts of it play complementary roles to fulfill one function.
Okay, I understand that, but where can I find that it says it's labeled positive and negative?
It's a convention. You have to fix it somewhere.
Yes, I understand that. Where can I find it, that convention? If it's so ubiquitous and clearly defined, it has to be found somewhere.
Yeah.
We use, how do you indicate radiation in all your relationship? In a relationship, how do you indicate radiation?
Yes, but that's not giving me the source of the positive and negative. Okay, that's okay. That's
Okay,
okay.
I don't want.
I can search it
I really
outside
don't
of
want
the
to
book.
spend time on these things.
This little thing says here that positive and negative refers to clockwise, counterclockwise.
That's it. It's a convention, but they are always like going different way. One is going out, the other one is coming in. That's it. In, out is a flow of energy. Energy goes out positively and comes in negatively. Energy disperses positively and gravitate negatively. It's a convention.
Thank you, Steve. I think we should keep that document that you have there. It explains it.
Okay, I already put this top paragraph. I put the top paragraph in this chat already, and I think I can get this in one move. Let's see if it'll go in.
Yes, I think that explains it.
Yeah, it seems to go in.
Yes, thank you very much. I appreciate that.
I still need to ponder it a little bit because it says here, alternation. These triangles are arranged on the surface of the sphere with the 60 positive and 60 negative triangles alternating in their orientation across the icosahedron.
Yes,
so I think as it turns around, as Manu pointed out in his little thing there, as it turns around, one is pointed up, the next one's pointed down. And as you rotate around, the opposites are opposite, like the spin on electrons.
Yes. Let's use left and right as in the definition, because up and down is a little bit itchy in this context.
Okay. Or this wants to say clockwise and counterclockwise.
Yes, clockwise and counterclockwise. Yes.
Yeah.
Sorry.
And
guys, I want to make a point here. If you get stuck onto your observation frame, you're going to get lost. You have to accept, as Joe said, that there is ubiquitous duality. And duality has to do with what is seen and what is unseen. What is seen is a cosine. What is unseen is a sine, is a cos. And you have to label one consistently through your understanding one sign and the other one another sign. The clockwise, you label it positive. The counterclockwise, you label it negative, and you keep it through your process of studying or understanding something. Then you'll be less confused. It's based on the principle of duality, And then you have to label one. The one that I see, I call it positive. The one that is still hidden in the alternance of things that I see. Because what I see it now. Next, I don't see it. It's gone. And what was not seen is seen. And that is the principle. Okay.
In the case of a tetrahedron, which is its own dual, how do you label positive and negative?
What do you say?
If this is a generalized principle, as you trying to explain to us, when you have a tetrahedron, which is its own dual, how do you label one or the other, positive or negative?
That's my answer to you. This is a tetrahedron in a flat. I put it together like this. Like that. I don't know if you've seen this. I've shown this many, many times. It's a paper model. It was like this. I turn here, I hold here, I turn there, and I hold there. That is a tetrahedron. That is a tetrahedron with holes. Yes. I don't know if you can see. Oh, the thing is.
I was playing with that today, literally.
Yes.
I found that in when I was packing.
That is it here. That is a dual of a tetrahedron. This is a 3 frequency. You can see it dual here. 1, 2, 3, 4, 5, 6. And you have these ones, the full ones. You can fold that into. I had it, but I have to glue this again. But that's it. I can take this one and do this. This is one fold here. And that one is the second fold. You can see some kind of tetrahedron here. Do you see it?
Yeah, and there's something that usually
it's not the best. I need to glue that side. Yes.
How does that make it positive or negative?
Okay. One is visible. Let me say it this last time. This guy is visible.
Tetrahedron is its own dual. How do you label one or the other, positive or negative? Clockwise or counterclockwise? It's not a generalized principle. You have an exception here.
There's no exception. This tetrahedron, this one that you see like this in the Star of David. This guy in relation to you is positive. That one is negative. What is the problem there? This guy is positive.
Okay, so it's not a property of the tetrahedron, it's a property of the observer.
No, it's the property of duality. That's what duality is. Okay, let's talk.
Yeah, okay, but if it's one label is positive, the other one's label is negative, it's a property of the observer which one is positive and which one is negative.
Of course. Your observer is inside.
Well, that's not what you say. That's not what you said. You said it's a property of... No,
okay.
That's not what you said.
I don't want to get into that discussion.
You said it's a property of duality, which is not. It's a property of the observer. You're muted, Manu. You're still muted.
Let's take it as you want it. I think that is a discussion that does not progress me.
Well,
Fred,
I disagree with that. I think we're making progress if we're getting more refined in our understanding.
Agreed. And taking your question to AI, I took that previous answer up here.
Yes.
And I went to and I said, does a tetrahedron have positive and negative triangles? Yes, a tetrahedron has both positive and negative triangles, similar to the icosahedron. This concept refers to the subdivision of tetrahedron into its smallest symmetrical components, orthoschemes or LCD triangles.
Yeah.
12 positive and 12 negatives. These 24
this is the icosahedron. This is the icosahedron with positive and negative. That's it.
Enantiomorphic mirrors images of each other. Wow, there's a new word. I've never heard of that one. Enantiomorphic. Enantiomorphic.
Enantiomorphic.
Yeah, enantiomorphic. Thank you. In Buckminster-Fuller synergetics, these are often labeled positive and negatives to distinguish between the left-handed and right-handed versions that cannot be superimposed on one another.
Mm-hmm. That cannot be superimposed on one another. It means also that are alternative. They cannot be superimposed. They are alternative. It's like this.
Well, the spherical icosahedron has 120 such triangles, 60 positive and 60 negative. The tetrahedron follows the same logic mirror image partitioning, but with a smaller total set of 24.
Yes. I thought that somebody was going to say, why does the sphere has 120? I have an explanation for that, but if we have... But in order to understand the 120, we first have to agree on the 12 of the tetrahedron.
I'm going to throw this in the chat as well. And here comes the last geometrical content, symmetry planes. These triangles are formed by the intersection of the sphere with the tetrahedron's planes of symmetry. Spherical area. In a spherical tetrahedron, each of these 24 triangles represents exactly 1/24th of the total surface of the sphere. Comparison, while a spherical icosahedron has 120 such triangles, 60 positive and 60 negative, the tetrahedron has 24. Can I ask it another question, Fred? Or anybody? Does anybody have another question? What determines a triangle as positive or negative in synergetics? Okay, good. We'll ask that. I would have thought it already had the answer ready because the question was there. In synergetics, whether a triangle is determined to be positive or negative is primarily defined on the enantiomorphic mirror image relationship and its functional behavior within a system. Handedness, chirality. The 120 least common denominator, the LCD, triangles of a spherical icosahedron are split into 60 positive and 60 negative versions. While identical in area and angles, they are mirror images that cannot be superimposed on each other. Okay, you know what? I understand chirality.
Yes.
And counterclockwise and clockwise was a little bit, is not as profoundly simple as the chirality issue of left-handed, right-handed. They cannot be superimposed on each other. Concavity versus convexity. While the mirror image triangles are vertex mated, joined at the corners in a spherical surface, their curved arc edges cause them to belly away from each other. If one is considered convex, curving outward, it's belly away from each other. If one is considered convex, curving outward.
It's very useful, Steve. Thank
Its
you very
counterpart
much.
is concave.
Thank you very much for that. Having handedness, concavity, and complementarity of physical behavior here together on one page, that allows you to make the distinction between many different figures. It's really
A
good.
broader
Thank you.
geometric context, the sign is often determined by the sequence in which vertices are encountered. A clockwise rotation typically results in a negative value, while an anti-clockwise rotation, counterclockwise orientation, results in a positive value.
What's very interesting is that in this quite full, complete answer, there's no mention of duality, which I believe we should avoid using duality to explain everything. It doesn't explain everything.
There is a mention of duality. What are you talking about? They don't call a name, but they define duality cleanly. This thing is at 180 degrees. This is duality. That is duality. That is duality. That is duality.
Can
What
we
else
get
do you want?
can we get a clear and bounded definition of duality?
That is the definition, the bounded duality definition of it. It's fundamental.
Yes, but what is the
If we
definition?
can agree on this, we have a problem.
What is the definition of duality? Steve,
That,
can you look it up on
well, you
AI?
are copying things,
I
copying
think
and
we need
pasting and saying that definition.
you can be
This
upset
is
as much as you want, Manu. We need
no,
to
I'm not
clarify.
upset.
Oh, well, you
I'm not
sound
upset.
upset.
I'm just
You
telling you the
sound
stuff.
upset. We
You
need to
do sound
define
upset,
duality.
Manu. You do sound
Okay.
upset.
We need to define duality.
Can you put your
because
headphones in? Your
I
speaker.
hear I hear a lot of duality
hear
being
you.
thrown around, but most of the time it's, in my opinion,
Oh.
not completely appropriate.
I'm gonna check out and see what that. I'm gonna leave this up here.
I beg to fundamentally differ with you. When I
Well,
say that,
well,
Yes, but let's define.
Hey,
Let's define it.
Manu,
Let's
hold it.
define it
Hold it.
before we
No,
start arguing.
don't
Hold
call
it.
Manu all the time.
Okay, I'm gonna mute everybody. I have everybody muted because I'm just saying here the word duality is actually stated in this definition. It's enantiomorphic duality or chirality. So evidently, and just as Manu was holding up his hand showing the duality, that concept is being reinforced right here. I'm going to unmute everybody now. I'm going to ask you to unmute. Yeah, go ahead.
Enantiomorphic duality is one type of duality. What we need to do is define duality, because duality is used for everything and nothing everywhere. We need to have a very clear, agreed upon definition of duality in our context, because otherwise you can call chirality enantiomorphic duality. It doesn't make it duality as we use it in our own context. It's one type of duality, but saying everything is duality, I disagree with that. We need to be more precise than that. So if it's chirality, we call it chirality, not just duality as if it's a magic word that encompasses everything.
I beg to differ with you. Nobody has ever seen that say that everything is duality. Nobody.
Well, that's my impression.
You stop.
That is my impression from listening to you, is that duality is the answer.
No,
to
don't
everything.
listen to others too. Don't only listen to me. That there's nowhere that I say that duality is everywhere. I say duality is ubiquitous. But I don't say that everything is duality. I didn't say that. It's like to say that
I did not claim
No, please let
claim
me.
you. I did not claim you said that. I said,
Okay.
in every one of your explanations or answering a question, you wave duality as a magic answer. That's so. Before we go further, I would like that we define precisely what duality is in our context, in order to be able to understand what you mean exactly. Because it seems from my point of view, it seems to be a magic word that replaces every other concept. So let's define it.
Okay, let me answer to this once and for all.
Let's define it. Let's get a definition.
Fred, you've spoken. I've listened to you. Let me answer. Don't cut me all the time.
The answer we need is a definition. And I think the definition we're going to get is that duality means different things depending on the context.
I lost audio. I've lost audio.
You've lost audio. I'm back.
No, I hear you.
Is everybody okay? I had to go take care of, I didn't have to, but I volunteered to go take care of Lee to make sure she gets in. And evidently she came right back in. So Lee, you're on and everything's good, right? Okay, so I'm sorry, I missed the whole conversation. Where did we leave off here?
We would like you ask your AI, if you have it available there, to give us a definition of duality in the context of synergetics.
Okay, now I did that. Let me see. This was my question. I said to it, it asked its own question. Do these concepts relate to duality was my question. Okay, and you want me to ask a different question. What do you want me to ask right now?
I would like to have a definition of duality in the context of synergetics.
What is the definition of duality in the context of what?
Of synergetics?
Of synergetics. I'm going to put this in the chat as well.
Yeah.
Okay. Oh, I was going to put that link here. Let me do that. Because this talks about tension and compression. Did we get this? Wow, did we get this part of the definition in there? I guess we only got the top part of this. Here's
For the most part we did, but I feel like we've covered mirror neurons. I don't know.
Complementary duality. Fuller often used these terms positive and negative to represent complementarity, a concept similar to yin-yang of physics. Convexity and concavity. Every system has an insideness, concave, and an outsideness, convex. The position and the positive and negative triangles represent the inherent disparity between these two perspectives within a single spherical system. Tension and compression. This duality is reflected in the physical world as always and only coexisting forces of tension and compression that maintain structural integrity or tensegrity. Now we're asking this question. Gosh, I don't think I asked, do these questions relate to duality? And this mentions the this mentions the thing. Pardon me as I pedantically go through this, just so we get all these parts.
It's okay. I think it's very important.
Yeah,
I
agree.
I think we should. This is very important concept, and making the distinctions between the different types of duality that are listed here is fundamental for us to go further in our understanding. We cannot
totally
keep
agree.
waving duality. We have to be more precise than that. If
I
it's
would like to be.
chirality,
Yeah.
if it's chirality, we have to say chirality, and geometric reciprocity is reciprocal duality. It's I think it's important. This I don't think we can keep going just saying duality for everything without being more precise.
Right. And it's wonderful, Manu, that you understand it and seem to understand it completely in your own mind. And the words you used were not relating to my paradigm. I was getting confused. And so bringing in new words is going to be helpful and help us understand this the way you understand it, or
Yes.
if that's possible, Manu. So thank you for sharing your thing here. The concept of positive and negative triangles in synergetics relate to duality in two specific ways. Now, I read this part, right? The enantiomorphic parity, mirror image duality as a structural complementarity. In synergetics, positive and negative are used to describe fundamental duality of the parity rather than the electrical charge. Mirror reflection. These triangles are dual in the sense that they are non-superimposable mirror images, enantiomorphs. You cannot rotate a positive triangle in 3D space to perfectly match a negative one. And I think understanding chirality here really helps me here,
Yes.
because I'm not sure I understand enantiomorphs, but I understand chirality, and it's the same word. I think they're synonyms. Inherent pairs, Fuller argued that unity is plural at a minimum of two. A system cannot have only positive triangles. They always coexist in equal numbers, 60 positive and 60 negative in an icosahedron, representing a balanced dual state of the universe. And now we're hitting topic number 2, geometric reciprocity or reciprocal duality. I'm going to stuff that in the thing here. Geometric reciprocity, reciprocal duality. Standard geometric duality, where vertices of one shape become faces of another, like the icosahedron and the dodecahedron, is linked to these triangles through the LCD, least common denominator subdivision, which I don't understand. The 120 triangles, the 120 LCD triangles of the spherical icosahedron are formed by the symmetry planes of both the icosahedron and its dual, the dodecahedron. Universal,
Steve,
yes.
what you just read, simple. Here it is.
Yeah, it's simple for some people. Go for it.
No,
Manu.
hold on. Watch what I'm saying.
That's what I'm doing. I just
Okay,
commenting. I mean,
okay,
please.
no, please.
I'm
Let me
agreeing
finish.
with you. I'm agreeing with you, and I'm pinning you to the thing so we can watch what you're saying. Go
Okay,
ahead.
can you watch what I'm saying, please?
Can we finish reading the definition before we have comments?
No. Okay. Let me say no to you now.
We have not finished reading the definition. And you have.
No, please.
Mm.
Okay, it's not always you. Please.
No, it isn't about always being one person or another, Manu. It's about finishing the definition.
You know, but it is systematically interrupting me. Systematically on this call.
Wait a minute.
I didn't interrupt you.
You are interrupting the reading of a definition.
I was reading the definition. I was reading the
Steve,
definition.
you were reading and you say you don't understand.
Lee has her hand up.
Okay, no, just stop that. This is
like
really going bad.
But I'd like to finish reading. May I finish reading? Okay, good. I appreciate your enthusiasm, and I want to finish reading. Here we're reading about complementary duality. Did I finish universal grid? These positive and negative triangles create a basic triangle grid that is shared by a polyhedron and its dual. This grid defines 31 great circles that govern the transformation between dual forms. Do I have that in the chat? Let's see if I do. Yes, I do. All right, great. Now we're doing complementary duality. Here we go. I'm putting that in the chat right now, so if you want to read along, you can. Fuller often used the terms positive and negative to represent complementarity, a concept similar to that of yin and yang in physics, convexity and concavity. Each system has its insideness, concave, and its outsideness, convex. I've read it before. The positive and negative triangles represent the inherent disparity between these two perspectives within a single spherical system. Tension and compression. The duality is reflected in the physical world as always and only coexisting, which is a Bucky quote. Forces of tension and compression that maintain structural integrity. I'm going to take this link and I'm going to put it in there.
Yes.
So if anybody wants to further investigate, they can do it.
Thank you very much, Steve. I think that helps a lot, this definition. It gives, we're not done. It gives a distinction.
You betcha. Now we come to your question, which I asked AI. What is the definition of duality in the context of synergetics, which was specifically your question? And here we go. In the context of synergetics, duality is not just a mathematical curiosity like vertex face reciprocity, but a fundamental principle, as Manu was saying, of universal complementarity. Buckminster Fuller defined duality as the always and only coexisting nature of opposites required to create a stable whole system. Duality in synergetics is characterized in 4 primary layers. I'm going to put this in up there. That's now in the chat. Okay, here. And this should have been there too.
The D.
What's that? The D. Yeah. Okay, good. Geometric duality, vertex face reciprocity. In standard geometry, the dual of a polyhedron is formed by replacing the vertices with faces, e.g. the icosahedron and the dodecahedron are duals, as for example, the icosahedron. Synergetic law, Fuller focused on the self-dual nature of the tetrahedron, 4 vertices, 4 faces, as a starting point of all systems. Now, see, to me, that is illuminating completely, because I've been hearing about how all these things, the vertex face reciprocity, I get it in the tetrahedron. That is cool. The grid duality is unified through the basic triangle grid. The 120 LCD triangles, 60 positive and 60 negative, mentioned earlier, form a universal mapping that defines the boundaries for both an icosahedron and a dodecahedron. Okay, I'm going to stuff this in to the into the chat. All right, good. Topological duality, insideness versus outsideness. Fuller argued that you cannot have a shape with only an outside. Duality represents the inherent disparity between convexity, looking from the outside, and concavity, looking from the inside. Disparate behavior. While the surface area is the same, the experience of positive convex triangles differs fundamentally from its negative concave counterpart in how they relate to a system's center. So I'm going to stuff that in.
That's
Okay.
interesting.
And here's this next word here, enantiomorphic duality, mirror parity or chirality. This is the positive and negative aspect you previously asked about. Right-left-handedness. All systems consist of non-superimposable mirror images, enantiomorphs. Unity is plural. Fuller, one does not exist in isolation. Unity is a minimum of 2. A system must contain both positive and negative components to achieve an equilibrium. Behavioral duality, structural complementarity. Duality manifests physically as the interaction of opposing forces. Tension, compression, these are the dual push-pull behaviors that maintain all structures, famously exemplified in tensegrity. Torque and counter-torque, the rotational movements in systems always occur in dual, opposing directions to prevent the system from spinning out of control. Wow. That to me is enlightening. Because when I consider angular momentum, I usually think of like a spinning top or a solar system or a galaxy. But to understand that it's actually counter-spinning at the same time in order to prevent the system from spinning out of control is a profound new insight for me. Thank you for letting me. Now, any comments on any of this stuff here?
Thank you, Steve. That's I think that was very important to do that, and having this in recorded in the chat. It's wonderful. Thank you very much.
Well, thank you.
My hand is up also.
Okay, good.
You can't see it because you've got it covered.
Yeah, I'm gonna.
But what I was wondering, in general terms, could I say that an individual has a positive that you see, but you can't see the negative that is behind?
Yep.
Is that what it means?
That's one way to look at it, Lee. Can we get a consensus? Does everybody agree with Lee that that's one perspective, one metaphor for understanding concavity and convexity? Part you can see and part you can't. And it's what I brought up, Lee, with the spinning galaxy, is that it's torquing, but it's also anti-torquing. But I can't see the anti-torque. But if the anti-torque weren't there, it would spin out of control. Yeah, that's profound for me. Any other comments or questions? Anybody want to jump in on Lee's statement or?
No.
Manu has his hand up.
Good.
I have a hand up.
Good.
Really?
Please do.
Yes. I really am. What I'm going to say is very profound. What I say on this call, I take risks.
Good.
And I work hard to say what I'm saying.
Good.
This discussion started, this part that has taken almost an hour, started by a question. Why do we use positive and negative? And I went very clear about it. Then I was attacked from, I'm using duality, I'm banding, it's been said here, that I'm banding duality to explain everything. That is insulting. Maybe it wasn't meant so, it is insulting. And I don't take that.
Well, you were not
No,
being
hold
attacked.
on. Let me finish. The last part of it is that on everything that you said, there is nothing that I've said that is contradictory to what we have exhaustively looked here. There's one point to say, I don't understand well. Can you clarify? Is another point to call somebody something by implying that what is using it abusively on this call. I don't take that. I spent 18 years or 20 years on this call. It's a lot of my time. Okay? Thank you. That's what I wanted to say.
Okay. And I'm, as mediator on this call, Manu, I want to apologize if you felt attacked or insulted in any way. If you give me a word or two and you give me an explanation and I don't understand it, it's certainly okay for me to ask for clarity and to go to AI and get another point of view. The AI actually said many of the things that you said, and it gave us sources for it. So that's really good. One of my favorite books is called The Four Agreements. And the four agreements are: 1, be impeccable with my word; 2, don't take anything personally; 3, don't make any assumptions; and 4, do the best I can. Please do not take anything personally here, Manu. You have a lot of energy. You have a lot of wisdom. You've been looking at this for years. I wish my brain was topological as yours, and my brain is not.
I wanted to share these two
Okay.
things. I was
Okay.
never given the opportunity to do it. Every time I wanted to show it, I was interrupted. And this I think will have helped us understand that very clearly. If you want, I take 2 minutes to do this.
Go for it.
Okay. This is on a plane. You talk of triangles on planes. The triangle is basically in 2 dimensions. This is the extensive, that is like this guy that way. If I roll this thing, I do folding that way, and I fold that way, 2 folding. This is what I got. This is a tetrahedron. This is made of 2 tetrahedra. One is the one that you see, that is in plain paper. The other one is the one that you don't see, that is in empty triangular faces. This is the 12 that they were talking about in the tetrahedron.
Okay.
This guy is the octahedron, the icosahedron, and the dodecahedron. The icosahedron is folded here. In whatever case, that's it there. These are the 20 faces that you see here, the 20 that I've numbered. These pentagons that you have here, and there are 12 of them, is the dodecahedron. And it is the dual of this icosahedron. Because if I fold this, folding them together is going to give me this. That's what I wanted to share. Because somebody say, how do you see positive and negative? This I see. What I put the number. I cannot put the number on this empty. I cannot number it. I can just imply it. But it is in there in tensegrity with this icosahedron to play this stuff. Here you don't see it because it is compressed down. It is folded. It becomes inside. I don't know how to put it here. I haven't put it together. But this, you understand with me that this dodecahedron has been compressed. That is, has been folded in the icosahedron. And that is the fundamental duality. You can't talk of a structure, and it was in your word that you read in the AI. You can't talk of a structure without the inside and outside. And they talk about it from the point of view of the observer. Do you want to observe it from outside? That is from the radiative part, or from inside, that from the gravitational part? Is the macro and the micro that we always talk about. It is a spin. It is ubiquitous. So to say that is part of this universe in which we live, I don't see where the problem is. So I'm through with that. It would have taken at least, like we've read all of those things, we can mark tones or volumes of definition, that is fine. But somebody comes out of it with a succinct summary that allows the person to understand. That was my point. Thank you.
Okay, thank you. Okay, any other comments or questions before we go back to this book?
Yes,
I
I
think
have a
okay, go
comment,
ahead, Fred.
please. I think it's a general principle that you never argue with definitions. You try to understand them. Because definitions are the basis, the foundation of our knowledge and understanding. And there's no need to argue on them. We just look them up and clear confusion. And it's a principle of clearing and Dianetics also. It's very clearly stated in the Dianetics handbook that in case of confusion, usually, I mean, it's not usually, it's in case of confusion, and that's a clearing process, that's a processing process, to use Dianetics vocabulary, is define one term in terms of confusion. Define one term, and the confusion is dispelled. That's the principle. So I will. I'm sorry. Manu felt attacked, but that's on Manu. That's not on me. I will never be sorry for asking for a definition and studying it, because this is foundational for us, all of us.
Yeah, I think that most arguments occur because people don't decide what definitions of the words they're talking about. And so
Yes.
one person is arguing apples, the other person is arguing oranges. And to ask for definitions, to come back to fundamentals, to first principles, is absolutely the appropriate way to avoid
Yes.
any kind of conflict. What? Go ahead.
I agree. And in this case, I think basically we all agree with Manu. He feels
Yeah.
attacked because emotions are high.
Yeah.
My frustration with the use of duality, the word duality, at every flavor, whenever there was a question, duality was the answer, or most of the time, the duality was the answer. My frustration comes from the fact that there are many types of duality, and we need to be more precise in our vocabulary. That's that's my point.
And I think
And
the AI did that.
yes, I think we got something that's was long overdue. I should have looked that up a long time ago, but I know this is a complicated subject, so it takes time and focus to go through it. So very much appreciate, and that's my takeaway.
Okay, good. We do have a little bit more time.
I know.
Okay, good.
That was to lighten the atmosphere.
So I want to go. Joe, do you have your hand up? You're itching your head.
No, I'm good.
Okay, good.
Manu has his hand up.
Oh, okay, Manu, go ahead. Go ahead, Manu. You're muted, my friend.
No, it was, I left it up. Sorry. It's down.
Okay,
And now that
good.
everything is clarified now, we're back to
Okay,
the
good.
stuff.
All right, wonderful. It's good to see you smiling.
And
It's
also
good to see you
duality.
smile. I agree with that.
No, duality is also to be tense and to be relaxed. Okay? Not to be tense and relaxed at the same time. There's a time for tension and times for relaxation.
Okay, cool.
It's to be offended and soothed.
Exactly.
Thank you for that mediation. I'm going to reread this because
a point. I can only say it to friends, the way I talk.
That's a good point.
I cannot, if I meet somebody on the street and we have an argument, I will never go that way. I can only say that of Fred because he's a friend.
You know,
right.
I'll just say this really quickly is, growing up, I remember going to one of my friends' houses and I had friends, all different types of friends. And one of my friends, I'm sorry, my parents were, or my family, it wasn't just his parent. My family was really arguing and, they don't usually yell like that. And I walked down and I was like, I thought they were talking. I mean, now granted that's what happens when you come from an Italian household, but it's like that, that's a conversation as far as I'm concerned. That was family talking. So I mean, to me, I don't see it as an argument at all. It has to really get to the point where, you take 10 years off from speaking to one another, and that's kind of an argument.
Right.
So
well,
that's one of
I do have those family members, but
that's one of the downsides of being on Zoom. We cannot just
that's a good that's a good point.
But we have evolved on Zoom to a point that we can express you can see, because by seeing me, you can see when I'm tense and when I'm happy. You can see.
Yeah.
You told me that you're tense. Yeah,
good.
You understand? You can see the build-up, and that is good. I think it's good this is an organic group. This is something that is evolving from physical to organic. It is an organic group, this thing.
Cool. I live next door to some Italians. So Joe, I know what you're talking about. I mean, they were at 150 decibels constantly in that household.
And that's a conversation.
That's a conversation.
I mean,
we were very quiet and very meek next door, I guarantee you. As we were having a conversation, but as soon as we heard the Italians, we just shut up.
Exactly. It's like, No,
Yeah,
it's a very intense culture. I'll just say
you
that.
betcha. Okay.
Steve, I
I-
would suggest that you read the 120 because I have a little thing to share
Okay.
that you will read. Yes. To that 120, the least common denominator or something.
You want to read something from the book, Manu? Is that what you're saying?
No, I said you will continue reading at about a
Yeah.
page.
I'm going to continue reading right there
Yes.
because I thought we read this before, but I think I didn't understand it, so I'm going to read it again. Thank you for being patient with me. Each triangle is split into 6 equal parts by perpendicular bisectors to obtain a final non-symmetrically divisible unit. This is 14.9a. This is 14.9a, maximum of 120 equivalent domains at the lowest common denominator. Why do we stop there?
Yes. And I wanted to share something right on that point. And I hope it's going to take us somewhere. I don't know if anybody remember. Can I share it?
Yeah.
Okay.
What do you want to share?
I want to share something on that. I said everybody understood how we get 120.
What now?
Yes.
Has everybody understood? If you have understood, everybody understood how we get to the 120, it's not necessary that I share.
I'm not sure how we get to the 120 because I want to know why we don't divide these triangles into pairs, except that by doing perpendicular along from this side to this point, they become non-equilateral. And if that's the stopping point, I get it.
Okay. Let me
They're
then just
non-symmetrical.
yes. Let me then explain something. You remember this figure? Do you remember from Wednesday? And
I'm not sure if I do. I maybe do. Yeah, I do.
but you remember if you take a circle, let's just take a plane.
Yeah.
You take a circle. You can divide the circle using an hexagon, putting 6 sides or 5 sides. You remember that? This thing.
Oh yeah.
You could put 6 sides or 5 sides. That was we studied this in cosmometry on Wednesday. Now,
Oh, yeah.
when you divide into 6, the 360 degrees is 60 each sector. 60 degrees. If you divide into 5, it's 72 degrees. Now, you are juxtaposing, they are dancing, they are doing this. 60. And now, what is the common denominator between 60 and 72?
12.
12. 12 is the minimum that you have a triangular structure, a triangular shape of any size. And I've did many configurations here. As you turn, you see, if you take the circle and you put the hexagon and the
That's
pentagon with the same, and then you start twisting, it goes, it has different shape. Do you see these two? Just the positioning. And then you count this. Look at what I call here the phi, because I define this as a phi. You see the ping one? If you count the number of ping one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And each, originally when everything is in equilibrium is 12 degrees. Now, when you take the sphere, how many pentagonal faces do you have on a dodecahedron?
20.
10.
4.
Yeah.
10. 1, 2. You
Okay,
see,
10.
1, 2, 3, 4, 5. Yes, 10. And each you can divide by 12 degrees.
How do you go from 2D
Uh-huh.
pentagon and hexagon to a sphere?
Okay,
How,
because I
how,
was
how,
seeing, I
how, is,
was
that,
seeing,
how is the
I was
transition
seeing,
working there?
I was seeing like this. I took this. If I take a grand circle here, I'm looking at a face. I'm projecting this onto a plane. If I project this onto a plane, I have the outline of a circle. This sphere. Project onto a plane like this. I have an outline of a circle. And then this pentagon, for example, that is right at the beginning, at the back here, where my foot, my hand is coming, I can project it onto the same circle and then it fits inside, like he's doing here.
Well, it's not circumscribed.
It is. Why? This is the outline of a circle. Here.
Yes, but the pentagon is not circumscribed because its vertices are not on that circle.
They share the same center, aren't they?
Yes, but the vertices are not on that on the circle.
Yes, but they are not projected at the same time. They are not all projected. Otherwise, you can't go out.
Okay,
They are
so it's
projected.
so you just circumscribe a pentagon into a circle. You don't need a
Yes.
dodecahedron for that.
No, you need.
No.
How do you find the set? How do you find the
How do you
12
go?
degrees?
Why do we go from 2D to 3D when it's not necessary?
Okay, show me how you. Okay, you dismiss my explanation.
I'm
Get
not
me.
dismissing it. I'm asking why do we do that? Because
Because
what you say is the outline of your circle, and then you have a small, teeny pentagon in the middle, and you say they are the one
okay.
fits with the other, and we just adjust the size. You don't need to do
Do we
that. You can just take
do
a
we decide?
circle, any circle, and draw a pentagon circumscribed. Circumscribed means that the vertices of the figure are on the circle.
And
Okay, I agree with you. But do you?
you're still in 2D though, right, Fred?
Yeah, I'm still on 2D. We don't need to go 3D.
Well, we're doing spheres though, Fred.
Yes, but Manu's drawing is a circle with a pentagon and a hexagon inside, and he's showing us differential rotation on it,
No,
and
what I'm showing you.
he's calling the intervals phi and pi, which I
No,
don't understand where
I
that,
didn't call them fine.
which I do not understand where that come from. But let's focus on why do we go to 3D in order to explain something here.
Okay, this is 3D, right?
Yeah.
Listen. If I make a movie, if I put a light here, a light from here, like the old projection movies,
Yes, you're projecting, yes. Then
what will it give me?
some shadow, something, we don't know. It depends where your light is and what the angle
No,
of
Okay,
it.
this is
it's
what's
gonna give
called
me something like this.
it's a stereophonic projection.
Yes, it's
Well,
gonna give me this.
that's a very special case you're showing. Most of the time you won't get that.
Yes, of course. The 12 degrees is very special.
No, not the 12 degree, the projection. You're saying you
Your
need to get
projection
that.
is a special
Most of the
case,
time you
Manu.
will not
Oh
get
yeah,
anything
but
like
I
that.
want.
You will get something
Okay,
that's not centered
I'm
and
in
with
3D. I'm in 3D, and I want to see something in 2D. I cannot see the same thing in 3D. We already know that it's a general principle. You knock out one dimension in order to see.
yes, but your projection is not going to look like your drawing, except in some very special cases where
That's
your
right.
light is at that
It's a
position
special
and
case
your
drawing.
screen is at that position and all
Of
that.
course, my drawing was a special case just to make my point.
Yeah.
This is not the general. It was to make my point.
Okay.
Okay, so you just explained how we get a pentagon and a hexagon circumscribing a circle using some
No, I'm explaining.
using some sort of projection that has to be very spatial. Okay.
Okay,
That doesn't.
no,
But it doesn't. It's not necessary to do that in order to have your drawing. So why do we go to 3D?
I didn't go to 3D. Steve asked me, what's the link with 3D? Maybe you didn't get the question when I was showing this.
No, that was not a question. That you said I have something to comment on that, and you first give us a 2D.
No, this is what I show you.
Yes.
As
yes, but this okay. In order to understand this, and phi and the pi and the 12 degree and 10 degree and the 10 surfaces you isolated, we don't need a 3D something. That
no, I
complicates
didn't.
matters.
No, this was just to show the 120 triangles. The 120 triangles that we talk about, that we end this thing with. Maximum of 120 equivalent domain.
So how do we get that? 120 domains.
I just show you.
Oh, I didn't see it. Sorry, please repeat.
For each of these, there are 10.
Pentagons.
10 pentagons. And each of these pentagon is circumscribed. It goes with an hexagon.
Goes with a what?
Around it. An hexagon. This is a pentagon. Look at this. Okay. You see this one? This is a pentagon, right?
It has a great circle around it, you're saying.
No, but look at this one. This is a pentagon.
Okay.
How many triangles equivalent you have around it that come at it? 6.
It's a pentagon with 5 sides.
Yeah, the pentagon has 5 sides. But how many triangles like this come at the 5 vertices of the pentagon? Can you see them?
No.
Okay, let me count them. Do you see this pentagon that I'm showing? Okay, let me get this red pen. This is a pentagon, huh?
Right.
This is 1 triangle.
Yeah.
This is 2 triangle.
Yeah.
This is 3 triangle.
Yeah.
This is 4 triangle.
Right.
This is 5 triangle.
Good.
That's 6.
What?
No, that's 5.
That's 5.
That's 5. Let me just see.
You've got 5 sides on a pentagon. You can only have 5 triangles hanging off of it, unless you're counting triangles off your vertices. But those are pentagons off the vertices.
Just hold on.
Okay.
1, 2, 3, 4, 5. Yes, 5 here. Okay, no, dismiss what I'm saying. Dismiss it. But okay, this is the thing. 1, 2, 3, 4, 5, 6. Okay, you see this face like this. This is a pentagon.
Yes.
This is a pentagon. When I project this great circle here, you see this outline here that I'm showing. Do you see the number of triangles that will be in there? On the outline, there will be 1, 2, 3, 4, 5, 6. 1, 2.
Sorry. Do it again.
Okay, let me count this. You see this? This is 1 here. You see number 1?
Yeah.
Do you see number 2?
Yeah.
Do you see number 3? Do you see number
4?
4?
Number 4 is next.
Yeah. 5. And then 6 here.
Well, you went up.
How is that a hexagon?
Yeah, you're going around the curve.
The disjoint triangle, they at most share one vertex.
Let me count again. 3, 3, 1. Let me glue this again. Maybe I'm making a mistake here.
Maybe you prepare for maybe you prepare for next
Yes,
week.
yes, I should prepare for
Yeah?
next time.
That'll
Yes,
be
next
good.
week.
That'll
Yes,
be good
because
because
it's I think you're trying to tell us something, but we can't see it, and
No,
it's a
yes,
little
I
bit
agree. I agree
confusing at
with
this
you.
moment.
I'll look next time. Call
Okay,
me on
thank you.
this, and then I'll say if it's right, if my argument is right, or if I'm convinced now that my argument is right or is worth presenting.
Yeah,
I've got my
in any case we get to learn something, so that's all good. Thank you.
exactly. And I think somehow your explanation has something to do with a great circle. But when I hold up I got one of those puppies too, Manu, because you helped me build it 3 years ago or whenever we did it. And there's my pentagon, and I've only got 5 triangles around that pentagon. Now, if we expand and we're trying to do a stereophonic projection from some great circle around this icosahedron, then that's something else, but I don't see it. So prepare for next week, Manu, please.
Yeah, I'm sure I'm making a mistake here, but
Okay, good,
I'll find what it is.
good.
It's okay.
And
While you're at it, Manu, I would like you also prepare an explanation on the 2D drawing of a circle with a circumscribed pentagon and hexagon,
Yes.
where you claim that one of the surface on the outskirt of it is phi and the other one is pi, because I do not understand that. And I would like to understand it in details. If you can prepare that, I would be very happy with that.
cool.
Okay, but that one has a very quick explanation.
Well, good.
The
Do it
cir-
next week.
Let's do this
Yes.
next week because it's
Yes.
time has arrived.
It's time to go.
Yes.
And I'm delighted that we're into this so deeply. I still I think I've got an answer to my own question about breaking it down, and we'll talk about it next week. We're going to end up on the same page. We're going to start on page at the top of page 240, where it says each triangle is split into 6 equal parts, and we'll go with this whole thing of the icosahedron. Manu, thank you for staying in the game. How are you feeling, and what do you take away today?
I feel living. I feel an organism. I feel organic, really. I feel living. Because, I've personally gone through all of the states, I mean, a lot of states of being organic. That is being alive in a way that it moves and then we see. I appreciate everybody. I appreciate your steadiness and your patience to put up my foolishness sometime. But I like to be foolish in order to understand. They say that sometimes the
If I'm
foolish
not
guy.
willing to look like a fool, I'm going to be lost. So good for you.
that's my takeaway.
Yeah.
So nothing, even if we take it personal in the call, it remains circumscribed. That's the boundary.
That's right.
The boundary is another of my magic word that I always put. There's a boundary. There's a boundary to that. And the boundary is not permanent because it's pulsative. It's changing all the time. So that's my biggest takeaway. Otherwise, I'm grateful and thankful. Joe, how do you feel? What do you take away?
I mean, I take away a lot. I mean, I'm listening and, not a lot of interruptions because there is so much to learn. Interestingly enough, what comes to mind is, I know that now you guys are going to be shocked by this, right? Batman and the Joker. And I'll explain why. It's order and chaos. And that's the duel. And so, and in thinking about it and from that perspective in particular, order is what we see from the outside, and you see the patterns and you get the repeatability aspect of things. And then you have chaos, what's on the inside.
Mm.
And that's the local. the uncertainty and sensitivity. And I've been doing a lot of thinking about that too. The local as well as the macro, if you will, micro relationship. But it also gets to, and this is why it's always so great to hear these conversations, is what is the tetrahedron then? And it's stable because it's at the most simple form, so that it can't be there can't be too much order, and there can't, and at the same time there's an element of freedom, and that's the tension and compression. So when you but think about that, all this is actually stemming from our conversation. And so it's just again, I'd thought about this only because of this conversation, but what I'm saying is, more than anything, okay, you think of something like Batman and Joker, and then you think of order and chaos, and then you think of the tetrahedron, and without this conversation, none of those connections get made. And that's how you learn, is that you have that repeatability of those connections that you make organically over time. And when you think about the tetrahedron from that perspective, as something as its most simple form, in that it's not overly ordered, and that it has a balance. I mean, there's a compression and tension. That gives you a new perspective. So let's just take the converse. Let's just say I don't show up tonight. I don't have that thought. And that's really the privilege. I find it really interesting that the models that you broke out tonight, Manu, because I was actually going through my things as I was cleaning out my house, and I came across those very models. And yeah, so and I was talking to somebody about them, and it's I just said, I said she said, "Oh, I'm not kidding." She said, "You know a lot." And I was like, "No, I know people that know a lot." And so by being here tonight, making those other new connections, it allows it's a privilege. And it's a privilege not everybody has. So I'm grateful for tonight. I don't think any of you really fully understand what it means to argue. So have any idea what it is. So it's
You try
but
us.
I think that you consider to be arguing is very amateur. So I'll just leave it at that. And so if there's one area maybe I should be speaking more to, that would be, I could educate you all on that. So Lee, how are you feeling? What are you taking away from today?
You have to unmute.
I learned a lot in all that each and every one of you said. You were very quiet, Joe, but I like your last statement. Yes, I know when an Italian family argue, because I had one across the hall from me who damaged my leg because he was so angry at the world, not me at all. I just happened to be in his way. And so I do understand where you're coming from.
Yeah, see, that's an argument. That's sorry.
Yeah, that's a real heavy. That damaged me for life. But what I liked was what Steve mentioned, that the circumference has to have another direction so that, such as the world, so that it doesn't get out spinning too fast, way too fast. You have to have it go the reverse or the negative side. And Manu, I was trying to get my hand up so that I could speak, but nobody was seeing because Steve had a black screen in front of my hand. So I missed out on all the conversation I wanted to say. You gotta spin backwards sometimes to get yourself balanced. And so there is a positive and a negative in everything that we do. Fred, how are you feeling? And what do you have as your final statement?
Thank you, Lee. I'm delighted to see how you, Lee, have opened up and gotten grounded and confident to participate and ask questions and stand your ground, share, and direct the call like you did for the, I think, Wednesday last week on AI and all that. So I'm delighted about that. And frankly, I find it's amazing. You were a little bit subdued and maybe timid when I joined 6 months or 7 months ago, but now you really opened up and you're joyful to learn and to share, and I very much like that, like to see that. So that's I wanted to comment on that and give you feedback on that. You're very welcome. I feel complete with the distinctions around dual. This was long-standing frustration for me, and I feel complete with the definitions we've all looked up and read together. This is, I think, very important to have those distinctions. There are other distinctions that we need to make, and I'll bring them up when time comes. One of them is derivative. Sometimes the use of the word, this is a derivative of this, or this derives from that, is used without fully understanding what it means. And so when that comes, I will ask to look up a definition, and then we can get more distinction about derivative. That as an example. I've spent many years wishing that engineers, scientists, mathematicians would have a place and a sort of ritual where they would gather on Sunday and sing little songs about dodecahedrons and differential equations and the meaning of the universe. And even though we do not sing little songs, I think I have found my place here with you all. And this is wonderful. Maybe we should have a little song, because Kelly, and this is something that does not come very often, even on the Wednesday where we talk a lot about music. Kelly always talked about rhythm and beat. And I think we should have a little song about the meaning of universe, dodecahedra, and the differential equations, so we can be happy and sing together and all that. And my last point is sort of a nudge to Manu. You need equipment. You need an overhead camera like the one I have. It costs very little money. So we have more clear drawings, and that you can write and point things out, write the name of things, make things clear, and a lot less of hand waving. See the dodecahedra here, nobody can see anything because it moves, because you've got a white shirt and the thing is white and all that. So you need an overhead camera. Yes, if you look, if you turn your desk around and hang the camera on your shelf, then you will have a space where you can make a drawing. And that's a suggestion. Maybe you can buy some sort of arch. Anyway, you need to solve that problem because you always have a lot of very interesting props that you want to show us, but then the feedback from me, the end result is a little bit disappointing because it's very hard to see things because you need more equipment than hand waving. So that's my takeaway. Other than that, I agree with Joe. This was very mild arguing. All right, Steve, how are you feeling today, and what is your takeaway?
Well, I got to tell you, I understand this icosahedron better than I have before. And as I look at this side, where I notice the pentangle at the top of this puppy is pointing down, this one's pointing up. Because as they're on opposite sides of the sphere, they are chiral. And so therefore, they are some kind of I don't want to say a dual relationship because there's a lot of duality when it comes to these things, but I will call it my new word, an antimorph of each other, or this chirality idea is really cool. And I'm seeing 2, 4, 6, 8, 10 triangles going around this great circle, the equator here. 2, 4, 6, 8, 10 triangles around 5 pentagon around, and then 1 pentagon on top. So I have never seen an icosahedron so clearly. Thank you, Manu, for waving this around, and so that I could go back and get it and look at it. Listen, I know that no one on this call would ever attack me personally. And if I do hear an attack, I think I am taking it too personally. So I just am grateful that we all came out with a smile. And there's an old saying in Mormondom, and I think it's true in Masonry, all truth will be circumscribed into one great whole. And the fact of it is, all truth is circumscribed into one great whole. And we represented that in this call tonight. We all hung in there and did a great job. I also so clearly got torque and reverse torque. I made a big thing. I have a memory peg on precession. I have Soviet P. It's a Soviet soldier peeing in the snow, and SOVIET. It's spin, orbiting. V is the vectors that are involved in it. I is in and out, and E is expanding and contracting, and T is torque and reverse torque. So there's all the elements in precession are on my memory peg. And I've said it over and over again. Spin, reverse spin, torque, reverse torque, but I never got it like I got it tonight. So maybe I have to be hit on the head sometimes to get something the way I got it tonight. A galaxy, and I can see it. I can see the reason why a galaxy or a solar system is spinning. It's also reverse spinning, and that reverse spinning is in the angular momentum of each of the objects floating around there, because while part of it is spinning with the orbit, another part is spinning away from the orbit. And I've had this big vision about the formation of planets, because as the angular momentum, the spin-off, the reverse torque collapses into the lower orbit and gets captured by the torque or the spin on the other thing. I've had this big vision. I am huge on torque and reverse torque tonight, and I just can't even believe it. I'm also better on this than I ever have before, and I'm excited that we're going to come back to page 240 and go through this whole mess one more time. Thank you all. See you next week.
Thank you very much.
Okay, bye-bye.
All right, bye-bye.
We're just not, we can't do last minute ideas. Hang on, let me end the recording. Bye-bye, everybody.
Good night.
Okay, here we go. The recording